Hello, welcome to Petrochronics, a research group and extension project focused on petrochronology and its geodynamic implications.
We are a group based in Brazil that also has an international network of collaborators. They presently reside in Brazil, Australia, Finland, Germany, Italy, Switzerland, and the US.
Petrochronology involves several areas of the geological knowledge. We seek to disseminate it in a judicious yet clear and accessible manner.
In our researches, we use macro and microscopic observations, combining fieldwork, detailed petrography, thermodynamic modeling, processes dating, geochemical characterization, and much more.
From the natural record, we seek to characterize and quantify petrological processes in representative samples, generating comprehensive datasets that are interpreted considering the geodynamic processes that govern the Earth system.
We want to share research, from the basic concepts to the state of the art, promoting courses, spreading work results, and providing collaborations between institutions and people.
We understand that open science is vital to take down barriers to knowledge, and we prioritize the collaborative and open nature of our research. We also propose discussions on integrity and responsibility in the scientific environment.
As values, we believe in diversity, representativeness, and access to information. We seek to mirror these values in our initiatives.
On the YouTube channel, we promote the PTT Talk series, which are presentations on methodologies and advances in cutting-edge research with petrochronology.
Our actions also include the organization of lectures, courses, workshops, and meetings open to the community.
On Instagram and Twitter, we share, on Tuesdays, photos of outcrops and rocks in the field, illustrating geodynamic processes.
And, on Thursdays, photos of thin sections with microscopic features with interesting minerals and textures, reflecting different reactions and petrological processes.
So, if you work with petrochronology or are interested in related topics, be sure to follow us and get in touch. We want our community to grow even more. See you!
So, hello everyone. So, first I would like to apologize for the delay. We had some issues with the time zone, the different time between Brazil and Europe. So, I'm sorry everyone, and sorry Ian. But today we are here for one more PTT talk, and we have the pleasure to be with Ian Francovschi, and we are here to host this talk. I am Catarina da Paz, a master's student at the University of São Paulo. I'm also here with Brenda Rocha, who is a professor at the University of São Paulo, with Rafael Mota, who is a professor at the Federal University of Rio Grande do Norte, and also with Ciro, who is a professor at the Federal University of Vales do Jequitinhonha and Mucuri. And thanks again for being here. Thanks, Ian, for accepting our invitation. It's a pleasure to have you here. And now I will pass it over to Ciro, who will introduce the Petrochronics.
Hello everyone, and welcome to the Petrochronics Research Group channel. For those who don't know us yet, the Petrochronics is a Brazilian initiative with an international network of collaborators from Brazil, the US, Australia, Italy, Germany, Switzerland, and Finland. Our main goal is to explore petrochronology and its power to reveal geodynamic evolution of our planet. We organize courses, lectures, workshops, and talks to share knowledge, promote geoscience, and build connections among researchers working in petrochronology. geodynamics, and related fields. So if you are interested in these topics, make sure to follow us here on YouTube, as well as on Instagram and on X, and stay updated on our LEAS activities and events. Here on our YouTube channel, we host the PT Talk series, a collection of presentations and discussions about new methods, advances, and petrochronology, featuring guests from around the world. Today, as part of 2025 season, it's a pleasure to welcome Dr. Ion Francovschi. Thank you so much, Ion, for joining us today. And now I will pass it over to Rafael, who will give us a short introduction of today's guest.
Thank you, Ciro. Thank you, Katarina. And hi, everyone. First, I'm glad to be back here at the Petrochronics PTT Talk series. And today we have the pleasure of listening to Ion Francovschi, who will talk about high-resolution geochronology. Ion is currently a researcher at the Geological Institute of Romania and at the Institute of Geology and Seismology of Moldova State University. His work covers geochemistry, paleontology, geochronology, with a particular focus on the East European platform, including Moldova, Ukraine, Romania. His research aims to interpret origin of phosphorites, distinguish between alluvial and glacial source, constrain the age of Ediacaran fauna, and understand the tectonic evolution of sedimentary basins. He holds a bachelor, master's, and PhD degree from the University of Bucharest, where he completed his doctoral studies in 2020. Ion also pursued a postdoctoral position at the same university and was awarded a Fulbright scholarship at the University of California between 2023 and 2024. In addition to his academic work, Ion has extensive experience in the oil and gas industry, having worked in several countries, including Romania, Russia, Cyprus, Morocco, Mozambique, and the Canary Islands. Once again, thank you, Ion, for sharing your work with us today. And now I will pass the floor to Brenda, who will introduce Ion's talk in more detail. Thank you.
Hello, everyone. Thanks, Ion, for accepting our invitation. So today, Ion will be giving a very interesting talk, talking about the combination of in situ and high precision dating techniques. So his talk today will be assessing the Ediacaran-Cambrian boundary in Southwest Baltica based on shrimp and CA-ID TIMS zircon U-Pb dates. So thank you again, Ion, and yes, you can start.
So yes, thank you, Ion. I wish you a great presentation.
Bom dia a todos. Thank you for the invitation. And guess I'll start. As you have already mentioned, the presentation is about the Ediacaran-Cambrian boundary in southwestern Baltica based on shrimp and CA-ID TIMS zircon uranium lead dates. So of course I'm aware that at the PT talks you usually discuss igneous and metamorphic rocks, but this presentation is going to focus on sedimentary units. So basically uranium lead methods nowadays are used for detrital zircon geochronology, which has well, several pros. Yeah, that's why it's being used. And as you can see, in the past decade, the number of publications related to detrital zircon publications or maximum depositional age publications has significantly increased because well, there are, as I said, there are several pros, some of them being listed here, such as the determination of the maximum depositional ages, provenance studies in order to understand the potential source areas for the sedimentary rocks, and the correlation of sedimentary units. Obviously, uranium-led geochronology is also useful for igneous, magmatic, igneous and metamorphic rocks, because over there you can probably as well determine the crystallization ages, the temporal events, and the well, they are also useful for magmatic and metamorphic rocks. Now, for uranium-led geochronology, there are at the present moment 3 methods. Well, these are LA-ICP-MS, SIMS, and ID-TIMS. So I'll discuss a little bit about the methods, and then I'll present a case study where their application is very useful. Okay, so the LA-ICP-MS method is probably one of the most used methods nowadays. It's one of the preferred methods because, first of all, it is very cheap. The costs are relatively low. It is very rapid, so you can make a lot of analysis within 1 or 2 days of laser ablation. It has a moderate resolution, so pits are typically around 30 microns in diameter and 10 to 20 in depth. And it has a, let's say, well, satisfactory precision of 1 to 2% with a 1 sigma uncertainty. There are also, these are the main characteristics, but LA-ICP-MS is also accompanied by some negative bias, by some cons, which I'll talk about a little bit later, but these are basically matrix effect, the inheritance issue, as well as lead loss. So the other method is SIMS, secondary ion mass spectrometry. In this case, the precision is basically the same as for the LA-ICP-MS method, around 1-2% with a 1 sigma uncertainty. The costs are much higher, as well as slower data acquisition, yeah, around 15 minutes per analysis. However, the pits are much smaller in comparison to the LA-ICP-MS method, around 7 to 20 microns in diameter and 1 micron depth, which is ideal for studies that require high spatial resolution, right? For example, you want to date a zircon that has several growth zones and you want to date all of them. As is the case for the LA-ICP-MS method, it also is characterized by the same cons, mainly the matrix effect, the inheritance, and potential lead loss. And talking a little bit about the matrix effect and the inheritance issues, well, these are not big issues because they can be easily solved, right? So the inheritance method, the multiple age domains, you can see in this figure with several examples. The potential problem with inheritance and multiple ages is by simply using cathodoluminescence imaging. So if we apply this method, we can see the zircons in detail. We can see the potential, let's say, 6 zircons, the ones that should be avoided, and we can eliminate them from the potential from dating from the analysis. So this con is easily eliminated. The matrix effect is derived from the heterogeneity of the zircon crystal, because besides zircon, There are obviously other ions in its matrix lattice, like silica, aluminium, and so on. So there's variation in the trace element composition, trace element content. Therefore, there will be some variable decay damage after the zircon crystallizes. However, this is also not an issue because it could be solved by simply annealing at 950 Celsius for approximately 48 hours, right? So by applying this method, we can repair some radiation damage within the crystal lattice. And after this, well, if we eliminate inheritance and the matrix effects, we still cannot resolve the issue with lead loss. In any case, after the LA-ICP or shrimp SIMS method is applied, we obtain different ages, and with the obtained clusters, usually the youngest clusters are used for calculating the maximal depositional ages. Yeah, this is one of the main applications of laser ablation nowadays, to understand the maximum depositional age, which in lots of cases represents the true depositional age of a rock. So there are different maximum depositional methods that are applied in order to calculate the MDA. And this is a list of couple of methods, such as the youngest single grain method, youngest cluster with a 1 sigma overlap, youngest graphical peak, youngest 3 grains, youngest 4 grains, youngest 3 grains that overlap within uncertainty, youngest cluster with a 2 sigma overlap, as well as the maximum likelihood model. And for example, the youngest single grain obviously is a very bad method and should not be used. The other ones are much better, but they still do not solve the issue with lead loss. So theoretically, from the provided list, maximum is considered, well, from a statistical point of view, that the maximum likelihood model is the best method to do maximum depositional age calculations. And basically the last method, which is CAID TIMS, this method is very expensive. This is one of its cons. That's why it's not usually used. It is, however, it is much better since it has a much better precision, from 50 to 100-fold increase in comparison to LA-ICP-MS or shrimp method. Yeah, so less than 0.05% to sigma uncertainty. It has a lower intra-grain spatial resolution, and it is it takes much more time to do the analysis. Yeah, from well, 10 to the first degree to 10 to the fourth degree seconds per analysis. In comparison to the LA-ICP-MS and SIMS method, this method is much better because before performing the analysis, the zircons are thermally annealed, and also chemical abrasion is being used, which has been shown to be highly successful to mitigate this lead loss. Yes, and it is also not susceptible to matrix effects. So this is just a small graph, a slide showing the different techniques that are being used for detrital zircon studies. The spatial resolution of the 3 techniques with the SIMS on the left side. We have the SIMS method with the smallest resolution, the LA-ICP-MS with the highest resolution, and the ID TIMS with an intermediate resolution. However, one should consider the fact that ID-TIMS is a bulk analysis. It's not a point analysis, like which is the case for LA-ICP-MS and SIMS.
Sorry for interrupting.
Yes.
I would like to ask you if you can speak a little bit far from the microphone, because there's a sound that I think is a bit weird, and I think it's because of that.
How about now?
Yeah, now it's better. Thank you so
Okay,
much, and sorry.
Yeah. Thank you. I didn't have time to, didn't manage to calibrate the microphone. In any case, for the ID-TIMS method, this is an image with a workflow. Probably not everybody is familiar with the workflow because most people work with LA-ICP-MS and SIMS, but it's not too different in comparison to the LA-ICP-MS method. So we have to crush the sample, sieve, wash, use the Wilfley table, use a magnetic separator and a heavy liquid separator. After that, we perform an optical selection. We can select the best zircon grains for analysis. It is advised, obviously, to thermally anneal them, and after that, the zircons are put into a mount. Since ID-TIMS is very expensive, pre-screening is mandatory in order to save money. Nowadays, a ID-TIMS analysis, at least in Europe, is costs 3,000 euros, so it's better to analyze in bulk with LA-ICP-MS a lot of zircons and see which ones we'd like to use for ID-TIMS. So either laser ablation ICP-MS or SIMS before ID-TIMS can be used, followed by chemical ablation. So basically, chemical ablation involves an acid bath, a strong acid, H-fluor, which will dissolve the more soluble parts of the zircon, which basically represent radiation damaged areas. So they are very susceptible, and when put into an acid bath, usually at low, not very high temperatures, for around 12 to 24 hours, these areas are removed. Therefore, this technique mitigates, solves the issue with lead loss. After that, an isotopic tracer is added, a spike. The zircons are cleaned, then put again into an acid bath. The temperatures are much higher, and they are left for 1 or 2 days. They are dissoluted, then a column chemistry procedure is followed. The uranium and the lead fractions are separated alongside trace element fractions. So uranium lead fraction is used for high precision TIMS uranium lead dating, while the fractions could be used for some trace element analysis. Usually they are used for hafnium isotope analysis. That's a very convenient way to use the trace element fraction. So this is an example of a zircon crystal that has undergone both LA-ICP-MS and ID-TIMS dating. I didn't mention, but you probably all know that zircons usually, when they crystallize, they retain the uranium, but they dislike lead, so they only have uranium in their composition, and after several millions of years, due to decay, uranium will transform from uranium 283 to lead 206 and uranium 235 to lead 207. So this isotope ratios are basically used for the determination of ages. And so this illustration highlights the use of LA-ICP-MS and ID-TIMS method. And obviously, if we want to I don't know, date some old zircons, and it's not imperative, it's not important for us to have exact ages, and LA-ICP-MS is a very good and fast method to do that. However, for some important magmatic events or some ash beds from sedimentary units, then obviously the errors that are obtained from LA-ICP-MS are not very useful, so we'll have a huge interval of ages. We won't know for sure what was the crystallization age. And in this case, as you can see, these three spots within the same zircon have yielded some different ages in comparison to the ID TIMS age, which is around 56 million years, and two spots have younger dates, and the third spot has a slightly older age than the ID TIMS method. Obviously, on the Concordia plot, you can see the huge interval that is occupied by the LA-ICP-MS results in comparison to the ID TIMS result. ID TIMS result. So in relation to the lead loss, which has been shown by several researchers, there are a lot of studies done in the past years regarding this lead loss. It has been shown that there is basically systematic lead loss in zircon crystals, and this is an illustration where how normally distributed zircon, lead, uranium values are influenced by lead loss. So there are, let's say, on the left side, there's this scenario where there is no lead loss, and in this case, basically the ages should be synonymous, should equate to the true depositional age, to the correct crystallization age. A second scenario where we have constant lead loss. In this case, we will have much younger ages. The obtained ages will be younger than the true depositional age. And third scenario where we have isolated lead loss. In this case, there will be a couple of zircon grains that will form, let's say, a small cluster with younger ages, then a second cluster that represents that should represent the true depositional age. And there are some statistics regarding the uranium lead dates acquired by LA-ICP-MS that didn't undergo chemical abrasion, and they are systematically younger than ID TIMS from the same zircon crystals by approximately -2 to -0.9 offsets in uranium lead dates. So this obviously represents an issue and leads to erroneous data when we are performing the analysis and then doing our interpretations for potential articles or manuscripts that we are writing. And obviously, since I did a short presentation of these methods, I had the same issue in the southwestern part of Baltica for the delimitation of the Ediacaran-Cambrian boundary. Basically, the Baltica represents a paleocontinent. Nowadays, it's also synonymous to the East European platform, and the East European platform of Baltica consists of 3 domains: Fennoscandia, Volga-Uralia, and Sarmatia. Sarmatia, which is located in the southern part, is mainly characterized by the Ukrainian shield, which outcrops and has been studied extensively by the Soviet, Ukrainian, and Russian geologists, as well as the Voronezh crystalline massif, which occasionally outcrops, but is covered by a thin sedimentary sequence. But it's still well studied. Over here, I think, is the Kursk anomaly located. So yeah, has been studied thoroughly as well. In the case of the Ukrainian shield, as you can see, it to the west, where the Moldova-Podillya basin is located, it dips towards the Teyser-Tornquist zone, or towards the Carpathian orogeny. Yeah, the Carpathian orogeny is situated here in the southwestern part, and over here, the basin is obviously consists of two units: the Ukrainian shield, so basically the Paleoproterozoic Archean basement, and a thick sedimentary cover represented by Ediacaran, Paleozoic, Mesozoic, and Cenozoic, siliciclastic and carbonaceous rocks. The Ediacaran-Cambrian succession is rather thick, yeah, up to 600-700 meters. The Ediacaran succession is widespread within the Moldova-Podillya basin, so it is everywhere. While the Cambrian formations outcrop only in the are encountered only in the western part of the basin. So in the eastern and central parts, there was non-deposition, or they were eroded. Now, because the Dniester basin, so this Dniester River, because the Dniester River, so this river over here, had a strong erosive power, let's say, in the northern part of the basin. It has managed to strip quaternary, Mesozoic, Paleozoic rocks, and that's how the Ediacaran and Cambrian formations are encountered in this area, in this blue box over here. So these Ediacaran formations have been studied for several decades, and besides the outcrops, there have been drilled multiple wells, multiple drill cores throughout the entire basin for exploratory purposes, and that's why the geologists have managed to create have managed to create a very detailed lithostratigraphic column. So when we go into the field, basically one might think that these rocks are, I don't know, neogene. They look unaltered, they're unmetamorphosed, well preserved, but actually they're 550 million years old. And because of that, as I told you, a detailed lithostratigraphic column has been created since geologists have worked extensively in this area and have also participated in drilling operations. So as you can see, the Ediacaran and Cambrian units in Ukraine, Moldova, and Romania are divided into groups, formations, and beds as well. Yeah, so they are very well detailed. In the past years, there have been performed several analyses, LA-ICP-MS as well as TIMS. Why? Because this area obviously, not obviously, but contains several intervals that are characterized by the Ediacaran fauna, the first multicellular organisms that have appeared on planet Earth. And in the Moldova-Podillya basin, the white sea fauna is widespread in this lower part of the Ediacaran sedimentary sequence. So it spans from the Mohyliv formation until the Nahoriane formation. And there are many monographies, articles, books, and ongoing studies regarding these fossils. They are studied. There are still articles that study this fauna. So a couple of examples of Terrasiana deciformis, Charniodiscus, and the most common Nemiana simplex and Beltaniliformis orchevaya. And uranium-led geochronology obviously is important because it is used to constrain the periods during which these fossils have lived, right? So in this red, you can see these red ages. These are ash beds, bentonites that were dated with TIMS, and you can see that the oldest ash beds are 569 million years old, and then in the middle part of the Ediacaran sequence, they're around 556 and 554. These are published data, and there's another one over here, which is not published. I did this analysis on some ash beds. It's 554 million years old. So basically, with these ages, we can constrain the Ediacaran fauna, and the dating with TIMS method proves to be a very useful method for that. Another important thing for using uranium-led geochronology is also constraining this Kotlin crisis, which is characterized by the abrupt disappearance of the Ediacaran fauna. So in this Kanyliv Group or Kotlin regional stage over here, Kotlin crisis, I think there's only one macroscopic fossil that has been identified, Vendela larina, and that's it. So it would be quite useful to use IDTIMS on some ash beds, which unfortunately are not present in the terminal part of Ediacaran or early Cambrian. To use IDTIMS to constrain this Kotlin crisis, is a huge anoxic event that led to the downfall of Ediacaran fauna, and then led to the appearance of the Cambrian fauna. In our case, in southwestern Baltica, it's represented by Sabelliditis cambriensis or different Parasabelliditis species. Now, the issue, not the issue, but a group of Polish researchers had the funds to perform before that, they had the funds to perform a lot of analysis on sandstones. So you can see these black ages over here, and the results were quite compelling and shocking because traditionally, and not only in Baltica but also worldwide, the boundary between the Ediacaran and the Cambrian periods is put below the Phycodes or Trichoficus pedum ichnofossil zone. And based on some bentonite ash beds in Namibia that are located slightly below, I think, or slightly above the boundary, slightly below this ichnofossil zone in Namibia, the researchers obtain an age of 538.8 million years. So this is the data that we currently have regarding the Ediacaran-Cambrian boundary. but in other parts of the world where we don't have ash beds at the boundary between the Ediacaran and the Cambrian, the Phycodes pedum ichnofossil zone is used as the main marker. Yeah. So in Ukraine, Moldova, the paleontologists have found this ichnofossil, and based on also lithological characteristics, let's say, besides this paleontological feature, the boundary was drawn over here between the Kanyliv and Baltic groups, or the Kotlin and the Rivne regional stage. So the Polish group managed to analyze a lot of sandstone samples from the from the lower part of the Ediacaran sedimentary succession, middle part as well as the upper part. So I put here the ages that they obtained from the upper part of Ediacaran sequence. This is also these are the plots, the histograms for the obtained ages, and starting with the Kotlin regional stage or Kanyliv group, they obtained these very young ages, so 529, 532, 531, 523, and their conclusion was that well, they also used the youngest cluster of at least 3 dates overlapping in the 2 sigma error. They did not thermally anneal the zircons before analysis, but they did use cathodoluminescence. So in this case, the rising problem is that they decided, well, they at least proposed and proposed to move the boundary between the Ediacaran and Cambrian from the Kotlin and Rivne or Kanyliv and Baltic groups to the Redkina and Kotlin, between the Redkina and Kotlin regional stages and the Mogilev-Podolsk and Kanyliv groups. Well, not me, but my colleagues and I slightly disagreed with this conclusion, knowing the potential lead loss issues. So we decided to further investigate this issue, and we decided to do some other analysis. So this is also a slide with the obtained ages and some cathodoluminescence images, of the zircons that were analyzed. You can see here with the yellow arrows some zircons that are too young, so they fit into the early Cambrian period, 530, 524, 518 even. Yeah, the Polish group was also let's say amazed by the results. They even made a second round of analysis. So we have 2 spots, like a second spot here, but they again didn't thermally anneal them. They didn't there was no chemical abrasion. Therefore, the second round of results yielded the same early Cambrian ages. So in this case, we went to some outcrops in order to sample some sandstones from the Kanyliv group, from the lowermost part of the Kanyliv group, where the Polish group started to obtain these early Cambrian ages. And northern Moldova, the border with Ukraine, this is the boundary between the underlying Kalius beds of the Nahoriane formation of the Mogilev-Podolsk group and the Pilipe beds of the Danilivka formation of the Kanyliv group. It is petrographically, it represents a very fine grain sandstone. You can see quartz feldspar grains within a calcite cement. So your let's say typical sandstone, nothing odd. And we performed a pre-screening of the sample. So we performed shrimp analysis at the Institute of Polar Research in Tokyo. Obviously, we obtained several clusters. These are two kernel density estimation plots, one with which included zircons from with a 10% discordancy or below, and another one with a 5% discordancy or below or lower. And in this case, yeah, the older clusters are obviously useful for provenance studies, and then we have this young cluster, which on this graph, well, in isoplotar, it will show you the graphical peak, basically 560, 570 million years old age. So although we obtained the same, we had the same issue as the Polish group. So with shrimp, we used cathodoluminescence. They were not thermally annealed, and there were a lot of zircons, let's say, that showed an early Cambrian age. You can see this detrital zircons that I have put into the slide, and their corresponding ages, yeah, from 512 till 540. Obviously, the youngest one looks quite, well, it's characterized by white thickness. We would just remove it from maximum depositional age calculations. And there's also, this is grain 130, yeah. I'm referring to also this one, grain 13, grain 106 look, well, quite with white thickness, but the other ones should be, well, okay, and still they have early Cambrian ages, yeah, which means that the boundary should be moved between theoretically, the boundary between the early Cambrian and the late Ediacaran should be moved lower, just like the Polish group proposed. And well, this is the entire, almost entire data set of the zircons. We analyzed 180 zircons, 108 were concordant with a discordancy 10% and below, and 68 with a discordancy of 5% or below. So at least 11 zircons yielded an age younger than the Ediacaran-Cambrian limit of 538.8 million years. And if we used all the statistical methods for the calculation of the maximum depositional age, yeah, you can see that the results also indicate an early Cambrian age. Yeah, if we include all the zircons, and what with the youngest free grains, it's 521. Youngest cluster 1 sigma, it's 528. Youngest cluster 2 sigma is also 537. Yeah, so it's still below the Ediacaran, early Cambrian, late Ediacaran boundary. If we exclude the youngest zircon, the results are basically the same. If we apply the maximum likelihood model suggested by Vermes and isoplotter, the results are also early Cambrian age, yeah, 515 plus minus 12. And in this case, if we didn't use ID TIMS, then one might say that, okay, these rocks are early Cambrian, and the boundary between the late Ediacaran and early Cambrian should be moved, based on Polish group, which used LA-ICP-MS method, and our results based on shrimp. But yeah, so the boundary should have been moved from here to here. But anyway, in this case we tried to perform ID TIMS analysis, yeah, to see whether this boundary should be moved or not. We obviously pre-screened the zircons by doing shrimp analysis, yeah, So we had the luminescence images of the detrital zircons from the lowermost part of Kanyliv Group, the Pilipi beds. We sent to them to the Geneva Group, and over there, our colleague thermally annealed them, applied chemical abrasion, and during chemical abrasion, as I previously told you, there should be a partial dissolution of a more soluble radiation damaged areas, right? When they are put into an acid bath and kept for 12 to 15 hours at 200, 300 at a low temperature. So my colleague told me that she put a lot of these young zircons into the acid bath, and all of them were disappearing, they are dissolving, which means that all of them were compromised by lead loss. So lead loss was the deciding factor that caused this apparently younger ages while using LA-ICP-MS or the shrimp method. And although lots of zircons dissolved after chemical abrasion, still luckily some of them did not dissolve entirely, and the ID-TIMS method was applied for those zircons. So as you can see here, a couple of zircons that were previously dated with shrimp, yeah, although had, let's say, these two zircons that had much younger ages, which were falling into the early Cambrian, 534 and 535, and this one, which was much older, 569. After the ID-TIMS analysis and when we were put on the Concordia plot, the weighted mean, the obtained weighted mean age resulted to be 553. Yeah, so 553, which indicates a late Ediacaran age. And in this case, as I previously told you, we had some ash beds over here, 554, 556 million years old. Most probably these volcanic zircons were recycled from the, let's say, overlying rocks and were deposited and then recycled and probably recycled again into this units of the Kanyliv Group. Yeah. So in this case, we have managed to demonstrate by applying ID-TIMS that that lead loss is it causes confusion, and in this case, when a couple of millions of years are enough to move the boundary between the Cambrian and late Ediacaran, yeah, it showed its importance, yeah, that we can obtain some true ages. So in this case, we propose to keep the boundary between the Ediacaran and Cambrian at below the Phycodes pedum ichnofossil zone, as it was previously proposed. And the ages obtained by the Polish group represent zircons not contaminated but influenced by lead loss, so they are not reliable. Their maximum depositional ages should not be used for such interpretations. Also, I'd like to add that we did manage to identify an ash bed in a drill core in northeastern Romania. Over here, this red rectangle, which is much located much closer to the Ediacaran-Cambrian boundary. And we don't have the funds yet, but when we do, we'll use, we already analyze them with LA-ICP-MS, and the obtained ages are also early Cambrian, yeah, which is probably a characteristic for all the formations of this Kotlin regional stage or Kanyliv Group, yeah, and we would like to use ID TIMS when we have the funds, since this is an ash bed and will probably give us a more precise age near the boundary between the Ediacaran and early Cambrian, yeah, in the near future. So the main conclusions for this I hope useful presentation is that although the LA-ICP method is fast, reliable, cost-effective, it has its own limitations. Obviously, there are 3 negative biases, which are the matrix effect, the inheritance issue, and the lead loss problem. So the matrix effect and the inheritance issue can easily be solved by thermally annealing the zircons before doing laser ablation in the case of the matrix effect, and using cathodoluminescence imaging in order to eliminate the inheritance issues associated with multiple age domains. But LA-ICP-MS or shrimp is not capable of mitigating the issue of lead loss. So in this case, ID TIMS should be used. Although it is expensive, yeah, if we have a huge data set, at least it's suggested to do 1 or 2 analyses with ID TIMS, because the results might be not the ones that you might expect. So in this case, we propose that the boundary between the Ediacaran and Cambrian should remain where it was placed in the past, basically between the Kotlin or Kanyliv Group and the Rivne Baltic Group regional stages based on the obtained results. This is it. Thank you for your time. Obrigado.
So, thank you so much, Ion, for your talk. It's a very interesting topic. It's very interesting to see the limitations of the methodologies and how these apply in real problems, and important to discuss like that between the limits of the geological periods. So thank you so much. And I'd like to invite everyone attending to the talk. If you want to send comments and questions, feel free to use the chat. And now we're going to start the discussion.
Sure, if there are questions.
So if the host, if you have questions for now, you can ask.
Okay, so while we wait for the audience to ask questions, I would like to talk a little bit with Ion. So Ion, your main focus was on the sandstones, right? From the data that you showed, and you are trying to find the ash bed to get a high precision age for this boundary for the Ediacaran-Cambrian, or you don't have the ash beds yet?
So the first focus was related to date these sandstone beds, right? Mm-hmm. To show, of course, sandstone beds are not ash beds or bentonites. Yeah, they do not represent volcanic events, but we wanted to analyze them to prove that the zircons that were analyzed by the Polish group, right? So they used zircons from sandstones to calculate maximum depositional ages, because nowadays there are lots of papers that use sandstones or even mudstones, zircons from sandstones and mudstones to calculate maximum depositional ages, because there are no ash beds. So in this case, they use sandstones to calculate the maximum depositional age. Yeah, there are no ash beds in the Kanyliv Group in Ukraine and Moldova at least. So when you don't have ash beds, the viable solution is to calculate maximum depositional ages. Based on their results, we obtained early Cambrian ages, but since they didn't didn't perform chemical abrasion, there is lead loss. We used IDTIMS to show that these zircons are actually much older, and due to lead loss, the zircons yield early Cambrian ages. But in the results that we obtained only highlight that these are some zircons from the older underlying units and should not be used for constraining maximum depositional ages. And obviously, the Kanyliv group might be early Cambrian, right? But we need ash beds to demonstrate that. So since we don't have ash beds and we only have the paleontological evidence, we will continue using this paleontological marker as the boundary for the
ichnofossil from
the I mentioned that we did identify an ash bed, but in a drill core in Romania. But since we don't have funds yet, we cannot analyze them. But when we analyze them, obviously those will represent volcanic zircons, so they will be able to be used as true indicators of the age of the formation.
Yes, ash beds are precious. The most accepted age for this boundary is based on the ash beds, yes, which is much younger, 2 million years younger than previously accepted before. And just another curiosity about the chemical abrasion technique. So you mentioned you've been doing for 12 hours, is that correct? Because if you stay like too long, the probability of you getting all zircons dissolved, and it's sometimes difficult to extract them. So just wonder if you don't do like a more controlled chemical abrasion, for less time. Less than 12 hours. That's what I mean. Because sometimes I have to do it for as low as 30 minutes when they are really high uranium. Yeah.
Unfortunately, you know better than me, because I did not participate in IDTIMS analysis. It was done by the Geneva group, so my colleagues. I only prepared the crushing, sieving, Wilfley, magnetic separation, heavy liquid separation, and until the cathodoluminescence imaging, and that's it. So we did the analysis shrimp, and sent them to Geneva. So I don't know the exact times. My colleague Maria Ovcharova knows much better. Then her husband Urs Schalteger has devoted several decades of his life to this subject. So there are some presentations also on YouTube where Urs he has some presentations where he discusses this method in detail. So he knows much better than I do. So I cannot tell you exactly how much time and how to apply this technique. I'm basically to combine all this stuff with everybody, find with whom to do LA-ICP-MS, with whom to do shrimp, with whom to do ICP-MS for trace element analysis, with whom to do IDTIMS, and so on. And it's a multidisciplinary. I'm doing multidisciplinary studies, so I'm not focused on only one instrument. And I cannot focus because in Moldova and Romania we don't have such advanced instruments. I was there as a guest 2 times. They showed me how it works. I prepared samples in their lab, and that's it. So yeah, this is
Okay, thank you, Ian.
the reality. Thank you.
I have a little curiosity about it as well. First, thank you for your presentation. It's very interesting subject, and high resolution geochronology is amazing to solve some problems. And you said that before the chemical ablation analysis, you have to do some laser or shrimp in the grains. So my curiosity is, what is the criteria to choose the grain that you go to the chemical ablation?
So again, Urs has probably a good presentation, but one of the main criteria is to eliminate zircons that are characterized by white thickness. As I showed you in the presentations, there are some zircons that were too white. Those are not good. There should be zircons that can have some margins that feel alien to the zircon. Yeah, we eliminate those. Then we look if there are a lot of let's say oscillatory zoning, growth zones, right? Because there could be different ages, yeah, in each of those zones. So we'd like to avoid those as well, because we need only the zircons that would represent the youngest possible age. Yeah, so maximal depositional ages, we need those. And after we analyze, well, at least do this this so-called screening, we use laser ablation or shrimp, but usually laser ablation. We obtain the ages. We see which ones are the youngest ones. Yeah, we simply write them down. They are already mounted. Yeah, we write down which ones are young, and that's it. I tell my colleague, okay, this is the picture with the zircons that should be analyzed with ID TIMS. The other ones should not be, because, as I said, the analyses are very expensive. You try to avoid all the zircons that are, are at least questionable, and keep the ones that look good, long volcanic zircons. Although this is a sedimentary rock, right? You might have rounded zircons that are usually old, Archean, Paleoproterozoic, but there are lots of cases, especially for Ediacaran rocks, in my case, where very long, prismatic, beautiful volcanic zircons. So you want to analyze those, yeah. This is usually the methodology to select the zircons, yeah. And I didn't provide them here, but I have some other sandstones or tufites, or that's tufites, yeah, potential ash beds, that I told you we don't have the funds to analyze them. So we have lots of volcanic beautiful zircons. So those ones will be picked for ID TIMS analysis, yeah, because most probably they represent the volcanic event that took place during, say, the late Ediacaran.
Thank you.
Thank you.
So, very great talk, Ian. I have a question. In a classical papers about the detrital zircons, we have magical numbers about the number of grains or analyses that could constrain the maximum depositional needs using LA-ICP-MS or maybe shrimp. For the TIMS analysis, do you have a magical number of analyses to constrain this maximum deposition needs, or maybe a number of grains, maybe of analysis?
For the analysis that have been performed till now by my colleagues, the number was around 5 zircons. This was
105.
5 for ID TIMS.
Okay.
5 zircons. Because I mean, will take a lot of time to analyze 100. It's not possible. You just pick the most suitable ones, and obviously you want to have at least 3-4 zircons, but we go for 5 as the number of zircons to have a good measured weighted mean value. You also need to be as close as possible to 1.
And a last question: what do you think about applied lead corrections in uranium lead analysis? Do you think that it's correct to apply when they are detected some common lead on zircons, or don't?
Well, for LA-ICP-MS, you mean?
Yeah.
Usually, yes, we do apply them, but I don't know if statistically speaking, I didn't see a huge difference in the obtained results. We have for LA-ICP-MS, we usually analyze at least 150 to 100 zircons, and the obtained results didn't differ that much. So at least for me, and the results that were obtained, I didn't see a huge difference when applying this correction. But they are used. I think it's a personal preference, personal choice.
Okay.
So,
thank you. Thank you, Ian.
Thank you.
So if you don't have more questions here with the host and no questions in the chat, I think we can thank you again, Ian, and also invite everyone that is attending to see our next PTT talks that happens in the end of every month. And also, if you have more questions about this talk, you can send an email to Ian. And yes, thank you so much, Ian, for being here and for your amazing presentation.
I hope you liked it. Thank you very much for the invitation. I'll send the link to my colleagues, and we'll watch it later.
Yes. So thank you so much, and follow us on your social media. And have a nice day, everyone.
Thank you, everyone. Don't forget to like this video and share with friends who can enjoy it.